All right, guys. So in this lesson, we're going to be talking about section 2.5 and section 2.6. But what we're really doing is we're just looking at the vocab for these sections so that we can then go ahead and apply it, okay? So in this first set, we have 7 different postulates. And obviously, feel free to pause me so that you can kind of write them down as I go along. But I want to talk to you about this idea of what a postulate is, okay? So what a postulate is it's this idea that is taken as true, but there's not a formal proof to back it up, right? So in this one, we're talking about the basics of geometry that we studied all the way back in section 1.1, but there aren't any formal proofs that are backing up these postulates, okay? So what I want us to do to start is we're going to read through section or postulate 2.1, and then we're going to compare that to postulate 2.3. And to see if you think that there's a difference. So if you look at postulate 2.1, it says through any 2 points, there is exactly one line. Okay, so through any 2 points, there is exactly one line. Now, compare that to postulate 2.3 that says a line contains at least 2 points. All right, so a line contains at least 2 points. So they kind of sound the same, right? But they're not, because it's all about what we're given and then our conclusion of that, okay? So in postulate 2.1, what we're given is we're given 2 points, and then what our conclusion is that there's exactly one line to go between them, okay? So we're given the 2 points, and then our conclusion is the line that connects them. Now, in postulate 2.3, though, all right, this one is giving us a line, but then our conclusion is that there has to be at least 2 points that are on that line, okay? So even though my figures look the same, all right, it's all about what you're given and what you're concluding. Postulate 2.1, you're given the points. We're concluding that there's a line that connects them. Postulate 2.3, we're given the line, and we're concluding that there's at least 2 points on it. Now, this is very similar to postulate 2.2 and 2.4, only this time we're talking about planes, okay? So if you look at postulate 2.2, it says through any 3 non-collinear points, there's exactly one plane. All right, so before I dissect this, there's actually some really important things in here, okay? Non-collinear is important, and exactly is important in this, okay? Remember, if points are collinear, they are going to exist on an infinite number of planes. But the fact that I'm saying that there are 3 non-collinear points, then those 3 points are going to lie on exactly one plane, okay? So what that means is I'm going to take three non-collinear points. All right, those are non-collinear because they're not on the same line, and there is going to be a plane that contains them, okay? Now, compare that to postulate 2.4, which says that a plane contains at least 3 non-collinear points, all right? So on this one, we're given the plane, and then our conclusion is that we have to have 3 non-collinear points on that plane. Okay, once again, it's all about what you're given and what you're concluding. Now, postulate 2.5 is one that's kind of new to us, okay? So what postulate 2.5 says is that if 2 points lie in a plane, then the entire line containing those points lie in that plane, okay? So let's start with a plane, and then let's put 2 points, all right, on that plane. What that means is that line that connects those 2 points also has to lie on that plane, all right? So the whole line also lies on that plane. Now, postulate 2.6 and 2.7 are talking about the stuff that we've talked about before, all right? So postulate 2.6 says if 2 lines intersect, then they intersect at exactly 1 point, okay? And postulate 2.7 says if 2 planes intersect, then they intersect in a line, okay? So what I'm going to do now, after you guys have paused me and you've filled this all in, all right, we're going to come down to this example below, and we're going to say which postulate verifies the truth of that statement. Okay, so is it 2.1, 2.3, 2.5, 2.7, etc. Okay, but let's clear up some of these things that are on here. It's kind of unclear. So this point right here is point Z. Okay, so that's Z. This is point Y. This is point X. This is line M, and this is plane B. Okay, so let's read the first one. So it says the points X, Y, and Z lie in a plane. All right, so points X, Y, and Z lie in a plane. This is going to be postulate 2.2 because we're given 3 points, and our conclusion is that they all lie in a plane. All right, next one says the points X and Y lie on a line. Very similar. This is going to be postulate 2.1 because we're given 2 points, and it says that it lies on a line. C says the planes A and B intersect in a line. That's going to be postulate 2.7 because it says that if 2 planes intersect, they intersect in a line. D says points X and Y lie in plane B, therefore line M lies in plane B. That's going to be postulate 2.5 because postulate 2.5 says if 2 points lie in a plane, then the entire line containing that then the entire line containing those 2 points lie in the plane. And then the last one, lines L and M intersect at a point. That's going to be postulate 2.6. Okay, so we're going to pause there, but I'm just going to kind of tell you where we're going to. What we're going to do now is we're going to talk about conclusions we can make. All right, so we're going to be using deductive reasoning in order to make these conclusions, okay? All right, I'll see you in the next video.